In previous video, we saw that formula we used in solving the example, and I mentioned that in homotopy HUP or HVP, you can define, or maybe first you need to define the linear operator. If we have a linear operator, the linear operator can be defined in two ways: f of x minus a to b kxt u of t dt. Either you can write your equation in this form, or you can write your integral equation in this form: kxt u of t dt. And remember that our integral equation is a to b kxt u of t dt. This is our integral equation. So we have two ways, or maybe I should write minus f of x as well. So we have two ways. This formula that we used earlier in the previous video, that was the formula which has been used in solving example. Let me just derive it for you over here. Suppose H is, so we derive from this construction, this definition of linear operator. H is written as UP 1 minus P, and remember that when we solved Fredholm integral equation, non-homogeneous integral equation of second kind, here we defined some f of u, but in that case, in the current case, we had first kind, and in first kind we only defined u of x over here plus p l of u of x. That's what we have over here. This will be equal to 0. The solution is u n 0 to infinity pn un. We put that solution into above equation. This is equation 1, this is equation 2. Put equation 2 into equation 1. Since this is our solution which contains embedding parameter. So equation 1 can be written as 1 minus p n 0 to infinity un pn plus p, and the linear operator is a to b kxt u of t dt minus f of x will be equal to 0, and we need to put the solution over here as well: n 0 to infinity un pn, so on. After simplifying, we can compare the coefficients. For clarification, I just expand this series U0, U1P, U2P2, so on, plus A to B, KXT, and that will be U0, and I also add this P over here, Pn plus 1. So U0, P1, U1, P2, U2, P3, minus, it should be right, yes, L of U, and there should be minus P f of x as well. If you multiply this P that was over here, if you multiply over here, then you should also multiply this to the f of x. Okay, equal to 0. So I compare the coefficients. P raised to power 0 will give us u naught. You can see that this is P0, the coefficient of P0. So we have u naught is equal to 0. For P1, for example, for P1, we have u1, the coefficient is u1, and then the coefficient of P is f of x minus f of x is equal to 0, and we have u1 is equal to f of x. P2, the P2 will be u2, this term. When you multiply it, you get u2. And then we also have uh, the term due to that, which is u1 minus u1. Then we have plus a to b kxt. This kxt will be multiplied with this term. We have u1 dt. There should be somewhere dt as well. Dt is equal to 0. So we have u2, u1 minus a to b kxt u1 dt, and if you continue like that, for example, if you compare P3, you will get u3 u2 minus a to b kxt u2 dt. Generalizing this term, we get un plus 1 un minus a to b, the kernel kxt un dt. So that was the formula that we used earlier, and I just prove it over here. So there are two things. You can use any of the formula. For example, if you just follow this linear operator, and you can get u naught, and there will be minus sign and so on and so forth, right? The answer will be the same. Okay. So let me just solve some other examples, some more examples on this method as well. So first of all, you must acknowledge that you don't need to solve this equation every time. We got this formula where we have u naught, u1, and this general formula, we already got this formula from homotopy perturbation method. So you need to use this formula only. There is no P involved, so on. P will be involved, but after getting this u naught, u1, and u2. Okay. P will not be involved over here. Let me just clarify it. you will just get the solution, which will be u naught plus u1 plus u2 plus so on, and then you get the solution. That's how you find the solution. There is no p involved over here, since we got the all the things have been done over here. So let me just solve another example. Suppose we have example. Suppose we have an equation, and the first thing we need to do, we need to find the convergence. We need to know the convergence, and the convergence formula is this one. And after solving it, you will get 2 by 3, which is less than 1. So according to this formula that we derived, our formula is, maybe I repeat again so that you keep this in your mind. U naught is 0, u1 is your function f of x on the left hand side over here. Then we have un plus 1, un minus 0 to 1, xt un t dt. That's what we have over here. And n should be greater than or equal to 1. So when n is equal to 1, we have u2 is equal to u1 minus 0 to 1 xt u1 dt. And we have, after putting the values, u1 is f of x and f of x is x. You can see that this is over x. So that is x minus 0 to 1 x t, and u1 is t, since it is a function of t, so we get t dt. After solving it, I directly write the answer 2 by 3x. Similarly, when n is equal to 2, we have u3 u2 minus 0 to 1 xt u2 dt, and that will be equal to 4 by 9x. And we have n is equal to 3 u4 u3 minus 0 to 1 xt u3 dt, and after solving it, you can, I think, solve it yourself. We get 8 by 27x. So the solution is u of x u naught plus u1 plus u2 plus u3 so on, maybe u4 plus infinite series. U naught was 0, 0 plus, what is u1? u1 is x, it is x, plus u2 is 2 by 3x, it is 2 by 3x, plus u3 is 4 by 9x, 4 by 9x, plus u4 is 8 by 27x, so on. Take common x from here, we get x, 1 plus 2 by 3, 4 by 9, 8 by 27, so on. And after solving it, you get the answer 3 from here. So the answer is 3x. So u of x is equal to 3 of x, and you can see that we get the exact solution. If you want to just verify it, verification, either this is correct or not, verification, we have the solution. I'm sorry, the f of x is equal to, and we have 0 to 1, 0 to 1 xt, and then In place of u, which is actually a solution, we put u of t, replace x with t, we get 3t dt. X is just a constant. We have 3t, 3 by 3, 0 to 1, okay? And we have probably, let me see, is this correct or not? Let me see that why this is not correct. Maybe I need to check that x 1 over 1 minus ratio is 2 by 3. This is the ratio. So we have 1 by 3. So it is actually 3x. So this is 3t. And then we have x. Then we have 3t cube 0 to 1 x. 3 will be cancelled, so we get 1, so x is equal to x, so there is no confusion. We get left hand side is equal to right hand side. So you can see that how beautiful this method is, homotopy perturbation method, and we get the exact solution. You just need to remember that we must show that this quantity is less than 1, otherwise your solution will not converge. So this was the last example in homotopy perturbation method. Thank you for watching.